Hello everybody, welcome to our first technical talk of 2022. My name's Dan Hood, I'm the CTO here at ClearEdge. To my left is Tom Kulish, our Chief Architect. So today we have a single speaker, and I'll let Tom go ahead and do that introduction.
Sure, so we have Justin Cronin coming to you to talk about how to build React apps with TypeScript. So we're going to do one speaker, and I'll give you a little more description about Justin. He's a 15-year SWE software developer, solutions architect. He has a Bachelor's of Information Systems from UMBC. Justin has built numerous systems, heavily focused on web-based UI development. His recently has been focused on GUI development using frameworks such as React and Leaflet and also TypeScript, which we'll be diving into a lot today. So during this presentation, we will be on, me and Dan and Justin, will be on live on the chat room, so feel free to add in any questions, comments, anything you want to share. We'll be able to respond to you. Also, we'll be giving away a drawing today, be your choice of a TypeScript book. We'll be giving away from three different ones: TypeScript Quickly, Mastering TypeScript, or Essential TypeScript 4 for beginning to pro. And Justin's going to show you how to become a TypeScript pro in about 50 minutes. So we're going to put a drawing link in the chat. So you guys should be seeing that now, and feel free to put your information in there, and good luck. So I think that's all we have today, so take it away, Justin.
Hello, my name is Justin Cronin. I'm a solutions architect here at ClearEdge. Today we're going to be talking about how to build React apps with TypeScript. So the agenda today is going to go over what React is, its overview and philosophy. We're going to talk about how it separates itself from the pack of the 8 million other front-end frameworks out there, how it's evolved over time as well. After that, we can jump into what a React component actually is, what constitutes it. After we get those basics down of how React components are built and how they're rendered, we're going to start taking a look at TypeScript and seeing how it works, and start shedding some light on some of the benefits that it can give us inside of a React application. After that, we're going to try to bring everything together, and we're going to take a look at what TypeScript looks like inside of a React application. And then we will talk about creating brand new React apps with TypeScript. And we're going to go through a quick sample to convert an existing application over to TypeScript to see the type of benefits it gains us. So, what is React, and how do we build apps with it? React is a front-end framework. It's focused on creating responsive UIs for the web and for native environments. We're only going to cover the web portion of this today. But I'm pretty sure that the majority of this talk will actually relate to the native aspect or native releases, but I'm not going to cover that. So React itself bases itself around encapsulating logic inside of components. In other frameworks such as Angular, you would see these things broken out across multiple files. You'd have a module, a template to make these components up. React doesn't go that route. Instead, elects to keep everything together inside of one file as much as possible. So that is that the application logic, along with your markup, or at least a representation of the markup, are all present in the same module. Other frameworks like Angular or Vue normally follow something like a model view, view model approach, or a model view controller approach. React doesn't really do this out of the box. It essentially gives you the space to build your components inside of a class or a function. And then from there, it's really up to you what the paradigm is going to be for your application. It's really best to take a look to see what the program needs are, and then adjust accordingly from there. When React first started, it was very heavy in the ES6 class land. It was a big thing during that time, and the way that you would create a React component is by extending React classes. That's changed over time. We've seen it in the latest versions of version 16 and especially in 17 that React is moving towards more of a functional flow instead. So rather than seeing class-based components, you'll probably start seeing function components instead. And then the last four things are just kind of some prerequisites to jump into this talk. I want to go over what a pure function is because because React is heavily based in pure functions and immutability and so forth. So a pure function is a function that you can take in arguments, and if it's provided the same input, it always provides the same output. So an example is here. If we have a function that adds 2 to a value, we will always get the same result no matter how many times we call it. So in this scenario, if we handed 1 over to this function, we would always get 3 back. The next part is going to be memoization. Memoization is the idea of caching results to reduce the amount of calculations that an application needs to do. So in our previous example, if we memoized this function of x plus 2, and the first time we fired it and we handed it a 1, we would get a 3 back after it added those numbers together for us. However, if we called it a second time with the same input of 1, the memoized function would then understand, oh, I've done this before, so I'm going to go ahead and just hand this result of 3 back rather than doing the calculation again. Then lastly, if we ever talk about equality in terms of values, it's important to understand that React is basing things in referential equality for objects and arrays, and value-based equality for native types such as strings, numbers, and booleans. So what constitutes a React app? It is just a collection of components. So it's a hierarchical tree that normally you start off with a single node or component which normally you see called app or something like that. And then from there, it's going to call the rest of its child components from there. And through that call stack, you build what eventually becomes your UI. As mentioned, the component is either a class or a function. We're only going to be looking at function components today, since that's the way the philosophy is going for React. And then the function itself, it has basically 2 properties, or 2 things that it must do. One is that it takes a single argument in, which is known as props. And then second, it has to return some type of either JSX or ability for React to render and mount the view onto the DOM. We're going to be using JSX today just because it is, once again, the going standard. This is kind of a strange point for people sometimes because your JSX looks just like markup. So it's a little odd seeing markup inside of your JavaScript file. So some things on that. One, it's not actual markup. It's just a syntax style. It's an extension on JavaScript. So when you see it, it makes it easier for the reader to consume. But when it gets shipped off to the browser, it's actual JavaScript. You don't ship markup this way. If you do find it jarring, or if you do find yourself in creating a React app and it feels rather uncomfortable, I really suggest just kind of leaning into it and don't shy away from it. I know when I first looked at it, it was a bit strange to see all of this stuff together, but over time, not having to jump file to file and having everything there together has really been a really nice experience for me. All right, so let's look at a sample component. Like I said, a sample component here is going to be our name and our name label component. As mentioned, it takes one argument in, which is props, and then it returns JSX, which you can see on line 4 there. Props is just an object. It can have anything on it. Whatever the caller is passing down is what props is. So one thing to understand about a component is that it will render when it's first mounted. So as soon as I call this component, it's going to render itself, and React is going to mount it onto the DOM. It will only re-render if a property on props changes. So in our scenario here, we have one property that we're expecting on props, which is called name. If name is there, then we are going to use it. If it's not, we're going to replace it with not sure. If we use this component and then we change the text of name from whatever we gave it the first time, it's going to go ahead and say, oh, this value has changed, so we need to give a new result. This kind of calls back to the pure functions that we talked about, and also the memoization that we talked about as well, because that's essentially what React is doing under the hood for you. Once we have name, we can then build our view. All that we're doing here is writing some JSX that builds a header tag, and we toss that name value in there. So if we went ahead and called this with my name as the name property, you would see my name is Justin Cronin. However, if we chose not to pass a name, we would see my name is not sure, just like this. So as mentioned, props in, JSX out. That's a component. So when a component only uses props, and that's it, it's considered a pure function at that point, because provide a certain input, we always get the same output. However, that's not always the way that things work in terms of applications. At some point, we're going to be storing and maintaining state. With this, a lot of other application or frameworks and JavaScript applications tend to start introducing stuff like global states or global objects or listeners that listen on objects being passed around. React kind of goes a different route, in that a component should have the ability to own its own state. The value itself is owned by the component, and even the way that state value is set is owned by the component as well. We're going to fire up some state for a component using the useState hook, which is included with the React library. There are a bunch of other hooks that you can use. However, we're not going to cover those today. We're just going to focus on the useState one. So now we had our first scenario when a component would render if its props changed, but we're also going to end up with a second rendering pipe, we're also going to end up with a second way to render or re-render a component, and that is when its state changes. So this is a component that's fairly similar to the one that we showed before. However, in this scenario, this component is going to have its own internalized state. On line 1, we can see that we have our component name, which is increment button, and it takes an argument as expected, which is props. Now this is going to be where the first difference is. This line here is going to tell this component that it now has its own component state, and that state value is going to be set to 0 to start. useState returns an array with 2 elements in it. The first element is going to be the actual value of the state property, and the second is going to be a function that allows you to set a new value for that state property. If you call the function setCount with a new value, then this component is going to re-render. If you call setCount with the same value, it will not re-render. It's also important to call out that if props changes, so we start off with button text set to a certain value, and then our state changes a little bit, but then we hand a new button text to props. Our state does not reinitialize at that point. It stays the same. It'll stay this way until the component is disposed of. You would actually have to recreate the component from scratch, as in like instantiate a new one to get it to reinitialize like that. So after that, we have our normal JSX return. This is a div, and it has 3 elements inside of it. It has a label, which shows the current count. It has an on-click event, which is, its text is populated by props button text property. And all that is going to do is when I click the button, it will call set count and add 1 to the count. And then there's a second button, which is going to just reset the count to 0. The way that you would use this is by just simply creating a new tag, or a JSX tag like this, with the button text of whatever you want. We're going to use click me this time. So we can demonstrate how this would work by clicking the button, and we can see that it actually increments. We can then click reset, and as expected, it's going to go to 0. So now that we've covered a bit of React, and we know that our component is simply just a function that takes a single argument in and can maintain its own state, we can now talk about TypeScript. So what is TypeScript? Why is it necessary, or why would you even want to use it for a React app or any app? So TypeScript is a superset of JavaScript. It sits on top of it. When the TypeScript package comes with a transpiler that will actually transpile any TypeScript that you write down to JavaScript. So even though you are writing in what is known, or what you would consider TypeScript, you are still shipping JavaScript at the end of the day. Most of the syntax is going to look the same. The big thing is that TypeScript gives you a way to describe the types of the variables and functions that you are working with inside of your application. It also ships with a compiler that runs before the transpilation step. This is beneficial because that means that before you even hit the browser, the TypeScript compiler is going to tell you if you have anything that is going to inherently break your application, which means those days of waiting for the build to run, bringing up your browser, refreshing or whatever, or waiting for the hot deploy to happen, just to find out that you misspelled something are kind of gone. You would instead get a compilation error instead, or if you're using an IDE that supports TypeScript definitions or TypeScript in general, you would actually get an IDE indicator stating that, hey, this isn't right. So you can explicitly define types inside TypeScript, but it's also smart enough to where it's going to also infer types for you as well. So at times where you don't necessarily want to go out of your way to define your type, the TypeScript engine is actually going to do that for you, and we'll demonstrate that in a second. The last thing is that, as you can see in the diagram, TypeScript sits on top of this idea of JavaScript next and so forth. That's important because sometimes you'll actually see newer functionality available in TypeScript that isn't available in the ES spec yet. A really good example of that are optional chaining and null coalescing. Both of these are pretty recent to the latest ES spec, I'd say in the last year or two if I'm right. However, these have been available inside of TypeScript for, I want to say, about 4 years now. It was either late version 2 or early version 3. So you get kind of a, not quite a bleeding edge, but definitely on the edge of new functionality that might be coming down in terms of the spec. So the benefits of TypeScript. The major thing, as I mentioned, is that you are now going to be able to figure out if the changes you made actually work with the application. Now you could do that before, but you were limited to the browser in terms of figuring that out. So you had to ship all the way over there to figure out what your console was going to spit out. Now instead you can have your compiler check for any type of obvious errors, be them type mismatches, misspellings, missing modules, so forth. Since we are defining our types inside of our application now, that means that along the way we are actually self-documenting. As of now, if you were documenting your JavaScript functions and variables, it might end up with you putting a lot of comments in place that seem redundant, or you're doing things like function headers to drive JS doc, which is fine. However, it leads to the opportunity for documentation drift, which can be painful at times. For instance, say you had a function that took in one argument and it was a number. However, your PO or production support comes by and says, no, there's a bug here, we've got to fix it, we got to get it out the door fast. You go ahead and you realize that this doesn't actually need to be a number, it needs to be a string. You go ahead and update all the logic for it, you ship it out the door, everything's great, and everybody's happy. However, you did not update the header comment. So now your IDEs are still reporting that this function takes a number, but it actually takes a string. While this seems pretty small in terms of impact, you can kind of broaden that out and see how this can be extremely problematic. If you are using TypeScript, you would actually have to change the type of the parameter coming in. So you would have to tell TypeScript that you are now accepting a string, which means that the compiler would now check for string, and any type of suggestions from the IDE or autocomplete would all drive towards that type instead. You don't have to do the second step, so documentation drift isn't nearly as much of a thing. The types also allow us to communicate intent more. A lot of times we try to do that with just variable names. So if it's a Boolean, we might use the prefix of is or has. TypeScript allows us to be a little bit more explicit about this by allowing our types to describe what is happening in functions with variables and so forth. Since the compiler has an idea, or it can trace where modules are being used and variables are being used now, it's a lot easier to identify a regression scope as well. Your IDE most of the time will actually show where things are being used, assuming that you are exporting them in a certain way, of course, which can make life way easier for your product owners and also your testers, so that you know even before you make a single line of change to your application, you can actually find out where these modules or these functions or so forth are being used, and what's going to break if you change just the type. As I mentioned, most IDEs support TypeScript, so instead of your IDE trying to derive what this JavaScript thing could be, it will have type definitions instead, so it will actually know, oh, you are working with an array now, you get these options off of it, or you're working with a number, or this is a function, so forth. So it makes life way easier in terms of context switching back and forth between different tabs and so forth. Speaking of that, it's not just your application that is going to be TypeScript ready, but most third-party packages ship with types now. For instance, Lodash, a lot of people use it. If you were to pull down the Lodash library, you would actually have the option to pull down the types for it as well. That means that you get documentation, and you also get type checking to make sure that you are using that function properly. So rather than you having to have your Lodash web documentation here and your application here and switching back and forth, you can have everything inside the IDE now. If you do need to drill in deeper, you can always look further in at the type definitions inside of your IDE as well. The big thing that I want to touch on is that TypeScript is JavaScript. There is, one just sits on top of the other. That means at the end of the day, when you ship JavaScript, which also means that the two can live in unison in the same exact application. You can have 3 TypeScript files sitting off to the side along with 3 JavaScript files. The TypeScript compiler and the TypeScript transpiler will understand this properly. So that means that if you have an existing JavaScript application, you don't have to switch the entire thing over in one fell swoop. You can take your time with it. The application that we're working on here started off with a full React, just regular JS application. We have an application that we're working on here that started off as a React, just regular JavaScript application. Last year, we started converting it over, and over the last year, we've gotten about 80% of the code base converted over. The last 20%, we either A, haven't touched, or the risk of changing those files just isn't worth converting them, so we will just go ahead and wait until we have to touch those files, or we have a refactor story that we can go through and change them. They work perfectly fine with the other 80% that is TypeScript right now. It would be unfair for me to give you a list of benefits and act like everything's rosy. I feel it's only fair to give you some detractors. Since you are describing your types now, you're giving definition, you are going to have to type more stuff. You'll be typing interfaces, type aliases, schema structures, and so forth. On paper, a lot of people kind of become gun shy to that because, I mean, we don't want to type more, we want to get stuff out faster a lot of the times. My pushback on that is that you're probably going to be doing this work anyway. You're either A, going to be writing code comments, which is going to do the same exact thing, it just won't work for you. Or you're going to be updating wiki pages, which for the most part are probably going to drift off of what the current definition is. So once again, not working for you. Or you're going to have to communicate it verbally or through chat. So no matter what, while you might not be typing it in the application code, you're still documenting this somewhere. Why not put it into the application and have it document itself instead? You also are going to need to do more fixes before you make it to the browser. If your normal workflow is I make a change, hot deploy goes, I check the browser real quick and everything's good, there's going to be a step in between, and that's going to be the compilation step. Some people prefer just going straight to the browser. Me personally, I find it to be a form of context switching. It makes it hard for me to maintain focus. I like the idea that the very simple things like, am I using something that could be undefined? So you might need to do more in terms of getting to the browser. The compilation step is going to be an extra step for you, but the idea of it is to allow you to catch errors that don't need to make it to the browser. If you are working on an object that is undefined, then the compiler will step in and say, hey, this is possibly undefined. You should fix this before shipping it to the browser, which makes sense. It's just rather than switching back and forth between browser and IDE, you get everything in one place instead. And then another detractor is, that people talk about is the fact that you have to provide more structure in your application as well. So since you're defining types, you need to talk about what these things are, when it should be, or when a value should be undefined, when it needs to be required all the time, what does the shape of this object look like? And you start doing this before you even write a line of actual shippable code. So before you even have a line of shippable code. Now, having these conversations up front before actually writing the application logic, I don't think is that bad of a thing. Questions like this are going to come up no matter what. The question you need to ask yourself is, do you want to have this conversation now before shipping code, or do you want to have the conversation when it's shipped out already, or during code review, or so forth? Having your types defined up front gets more people involved, and it gives people more common understanding of what you're actually building. Okay, so types. How are we writing them? How are we using them? What do they look like? So, the first thing we're going to touch on are just some basic assignments. Our first line here is a counter. It just stores a number. We explicitly define the fact that it's a number by using the syntax of colon and then the type. But we don't have to actually explicitly define it if we don't want to. The TypeScript compiler is smart enough to figure out that you've assigned the value 0. So my inferred counter in this scenario has to be a number. It can't be anything else. The next thing is an object. So we can describe objects to the whatever level of fidelity that we want. In this scenario, we have an object that has 3 different properties on it. Property A, property B, property C. A is a string. B is a Boolean, but it's optional. That's what the question mark denotes. We can actually give undefined for that value here. And property C is an array of numbers. So when we initialize it, we can now put property A in as a string, property C in as an array of numbers. We don't have to give property B because it's okay being undefined. So objects and values and stuff like that are all well and good, but what about functions? So you have the 2 different ways of declaring functions. You have your normal function block, and then you have your variable functions as well. So we'll go with the function block first. In this scenario, we have a function called sum. It takes 2 arguments, A and B, both of which are numbers. The colon after the closing parenthesis shows that we are going to return a number from this function. We then return A plus B. We know that we're going to return a number because A and B can only be a number. That's the only option. If you try to call sum with a string or a Boolean or anything like that, the TypeScript compiler is going to step in and say, you can't do that. You need to give it a number. So we're guaranteed that adding these 2 together will infer a type of number. The function variable is a little bit different. Still the same aspects though. It goes back up to how we declared the type for number and or for my counter and the object as well. So on the right side of the colon, we are going to say that we have a function that takes 2 parameters. Once again, A and B, both number, and the fat arrow there shows that we are now returning a number, just like you would with normal fat arrow syntax. So to the right of it, we assign it function A and B returns A and B. So next, we need to take a look at how we can maybe be a little bit smarter in terms of how we define types. Going through and writing that object definition that we had on the previous slide over and over again is A, taxing, and B, if you ever have to change a type, it can be involve an extreme amount of effort of just doing basic stuff. So in the spirit of dry, we want a way that we don't repeat ourselves. That's where type aliases and interfaces come in. Type aliases are going to be are denoted with the keyword type. Interfaces with the keyword interface. All these are just type structure. You can assign them to variables or functions or anything inside of your application, and you can use that instead of having to type everything out. One of the big things that I do want to touch on is that typings don't ship to your ship with your application. When it transpiles down to JavaScript, all of these types are tossed aside. They're only needed for the compilation step. So if you're worried about bloating your application with types like this, your user won't actually incur any of that cost because they never see it. When you look at your payload, we don't ship types at all. So interfaces and type aliases and stuff like that, they all get left behind. All right, so type alias first. You use the keyword type, you give it a name, and you assign it an object. That object is going to be the structure. So we have this type alias of my category. We use the type keyword, the name, and then we assign an object to it. That object has the structure of what this type is going to be. So we have a type, which is of type string, and we have a count, which is of type number. We can then use that on line 7 to initialize an object where we give both the type and the count. Both of those match the type, so this compiles perfectly fine. Interfaces are very similar to types. In this scenario, we basically spin up the same exact structure. In terms of which one you want to go with, is it a type alias? Is it an interface? I'd say probably 90% of the time, it's going to be whatever your preference is. There's no necessarily right or wrong way to do it. I'm sure there are situations where you would prefer one over the other. But when you're first starting out, I would say pick whichever one feels natural to you. I find people that have back-end experience tend to gravitate towards interfaces just because that's where they've come from, while front-end developers tend to operate with objects and so forth, so they go towards type aliases. But whichever you prefer. So now that we've defined some types, we could just keep assigning them to variables and functions and stuff like that, but you can also do some other things with them which are pretty neat. So in TypeScript, you can not only use these to describe your variables and your functions, but you can also use them to compose new types. The first way we can do this is through unions. Unions will go ahead and allow you to define multiple types for a type. So in this scenario, we have category, and we are saying not only is category a string, but it's either going to be this string cat A, cat B, or cat C. Any other string value or any other value that is not one of these three strings is not valid. So you can use unions to filter down the types that you actually accept, or you can use them the other way to expand. You could also be in a situation where you have a function that can handle both a number and a boolean. In this situation, we could also use the bar to say number or boolean, and that would work the same exact way. The next way is through an intersection. That is going to interrogate two different types and find commonalities between them. So in this scenario, we have a type on the left, which is an object which has A and B in it, and then on the right, object that has A and C. Since the only commonality between these two is A, which is a string, we're going to take that, and that's what, so common property will now be an object with one property in it, A, which is a string. With interfaces, you can also extend them using the extends keyword. If you're familiar with the ES6 syntax, this is how you would extend off of a base class or something like that. It's just important to understand that, once again, it's an interface, so it doesn't actually ship with the application, but it still works kind of the same way in terms of how you would extend a base. So we have this interface, it's called iHasType. The type is category. So now, instead of having to put type and category all over the place, I can now extend iHasType on my new interface, iMarketItem. Now iMarketItem has a name property of string and a type, which is of type category. Next up is generics. I'm not going to dive super deep into this. I just want to get enough to where when we get into the React typings, it's not super jarring. So generics are essentially a way for you to pass parameters to a type. What does that mean? The best way that I have to describe it is by giving you a built-in TypeScript example. So on line 2 we have full obj, which is a type alias that takes, which is an object which has an A property of a string and a B of a number. Those must be given. Undefined is not an option. However, what if we were working in a scenario where we might not get that full object? It's pretty painful to go through and say, oh, well, now I got to make a new type alias that allows these to be optional. And you don't want to be handling undefined all over your application, so you're looking at possibly writing this thing in two different places. What you could do instead is use the partial type, which ships with TypeScript. Partial takes a type parameter, and we're going to hand it our type alias, which is full obj. When we come back, or what gets returned from this is a new type, which we're going to call partial obj, and that is actually going to have each one of our properties set to optional. So now it would be just like we rewrote our first type alias, but we put question marks next to A and B. So now, if we use this new type, A could be undefined and B could be undefined. You can also use generics and functions. So in this scenario, we have a function called justReturn. It doesn't do anything too crazy, it just returns whatever it's given. But I want to call attention to the type parameter that's given to the function, which is t. So t is going to be whatever, or whatever a is is going to match T. So if A is a number, then we're going to return a number. However, we can call the same exact function again now with a string. And TypeScript understands now, oh, A is now a string, so I'm going to be returning a string. So now instead of you having to write 4 different versions of a single function just because it returns or accepts and returns something different, you can use generics instead to get some reusability out of it. If you use classes in JavaScript, then this will look familiar as well. In this scenario, we'll use generics on a class instead. In this scenario, we're going to have a generic type parameter that we call TID, and it's going to be used to determine the type of ID for this class. So on line 17, we can see that we declare a public field called ID, and it's of that type that we give. So if we were to declare a new object based on this class, we could say we're working with a number for our ID, and that number is 1. So if I ever queried my number ID object .id, it's going to be a number in this situation. However, if I spin up another one, which is a string ID, if I do that, or if I pull ID off of this object, it's going to be a string instead. So, as I mentioned, generics can get pretty complex pretty quick. We just need that primer just to understand what some of these React types do. Next up is 2 types that are built into TypeScript that you might see along your journeys. The first one is any. Any is essentially you saying this value that I'm working with, be it a function, be it a variable, whatever, it could be anything. I know what it is. I don't need the compiler helping with me, or helping with this at all. So if you have an object, you don't really know the structure of it, you could use any, and you're basically operating just like you would in JavaScript. You can call whatever you want off of it. Unknown is the opposite. It is literally we have no clue what this is, and we're going to assume nothing lives on it. So for unknown, unknown, you must cast it to a known type to actually do anything with it. Any is an optional cast if you want to be a little bit more explicit with it. So I call this out just because you will see these along your travels, and sometimes the compiler will yell at you for not accounting for these properly. I'd mentioned casting. You can cast to whatever you want, given a certain type, as long as you give the compiler the proper cast steps. So in our first example here, it shows that we are casting a value on an object to a string. That object is any, so the compiler has no idea what it actually is. This is us telling it, no, value is a string. Normal cast uses the angle brackets, and you just give the type inside of it. However, if you're working inside of a JSX or a TSX file, this is going to be different because those tags are reserved for JSX markup, or JSX style markup. So instead we have to use the verbiage as type instead, which follows. All right, so bringing it all together. So we've gone through the basics of React and the basics of TypeScript, but how do they work together? Why do we need to bring this thing in? If you remember back to the beginning, we had mentioned that a component takes in props, and that props could be anything. We also have state, which gets initialized, and those the state values can also be passed down through props, and the functions to set that state can be passed down through props. The issue here is that none of the typings are actually shipped with these things, so we have no clue what we're actually working with. When I spin up a brand new component that someone handed me, I don't know what the props needed for that are unless they provided me separate documentation, or I have to dive into the source code, or I just have to do trial and error over and over again. State can be even worse because your application is now handing out functions to set state in another component, and now since you're not communicating the type that you need, whoever has that function can call it whatever with whatever they want. In our situation before where we set a counter, we could hand that set count function off, and someone could set that to a string, they could set it to an object, they could set it to undefined, and in that scenario it could blow up the application. It would be a lot nicer if we could describe all of these things with types and have the compiler check to make sure that all of these things are being built and used properly. So that's where TypeScript comes in. So, how do we type our props? We know that we have that one object coming in, but we need to give it some structure. So the first thing we're going to do is we're going to declare an interface for our props. Here I have something called iComp props. It is used for the comp component, which is located on line 10. This interface has two values on it, or two properties on it, which are a value and a count. I use the interface here. You can definitely use a type alias. It's totally fine. So now we have our interface, we have our structure. How do we tell the component that this is what it expects? Our first way to use it is through the built-in type of React function component. So this is going to be a type alias that essentially says this is a function that takes in a props object and it returns JSX. That's all the type alias is. So you use the type parameter that you're provided to hand off your prop structure. So now it's a React function component of type iComp props. So this tells TypeScript that your props object has both value and count on them, and they have the given types. The only thing that's not communicated explicitly here is that when you use React function component, it's also going to throw the children prop on there. This normally isn't that big of a deal, but if you are looking to be completely explicit, it's important to know this because this function or this component is a little disingenuous since we're saying we accept children, but we don't do anything with it. We effectively throw it away. So just to be mindful about that. If you don't want to go that route, you can instead just type the parameter like you would with anything else. So here we say that our props are a icon props, and that's the argument that we take in. This will not include the children prop, so we don't have to worry about that being on there. But if you do accept props, or if you do accept children, you're going to need to put that on the interface or type alias that you build. If you remember back to interface extension and unioning, you can actually build base types that you can use to make that a little bit easier for yourself. The other thing the other differentiator between the two ways is that the first way, when you hover over top of your component, it's probably going to show you the type alias. It's going to say, hey, this is a React function component of this props. The second one will not say that. It'll say it's a function that takes this type of prop argument and it returns JSX. So you get the full function signature. Once again, it's subjective preference, whichever one you want to go with. And then to use this in an incorrect manner, we could make a component, use comp, give it value equal to the number 1, give some text inside, and go from there. If we did this with TypeScript, it would yell at us for two reasons. One, we handed value off as a number, and it's supposed to be a string, and we didn't provide count. So in your IDE, you would probably get a red squiggly underneath of this and a suggestion saying, hey, you need to fix these things. So now let's go over to the use state hook. Originally, this is the same exact line that we have with our increment button component, and we're doing the same exact thing. So we initiate this state property to be 0. However, when we do this, TypeScript is going to infer that 0 is a number, so count has to be a number. setCount is now a function that takes one argument still, but that argument has to be a number. If you hand it anything else, you're going to get a compilation error. So this next line, if I try to set it to undefined, TypeScript is going to yell and say, nope, can't do it. However, line 6 works perfectly fine. If I want, I can also explicitly type my state property. So in this scenario, I don't want to provide an initialized value. I want it to be undefined to start for whatever reason. So big count now is, instead of being a number or undefined, it is either number or undefined by us using our union operator there. Set big count is now a function that accepts one argument. It can be either a number or undefined. So if I come down here and I try to console log big count out by calling toString on it, if you've ever fired up your app and you see cannot read this property of undefined, that's what line 10 is, and it's going to yell at you before you even make it to the browser. It's going to say, big count might be undefined, you need to handle this. And the easy fix is you use optional chaining here, and you're taken care of. So now we've seen TypeScript inside of React. It seems like we only did 2 tiny things, but with those 2 tiny things, we've effectively communicated out to our consumers of our components what we expect. And it gives them some guardrails to build their apps with. It makes context switching drop down. We've added a compilation step that ensures that our application at least builds properly before we ship it out as well. So you say, I'm ready to go. I want to create a brand new React app with TypeScript. You can do that very easily. The only thing that you have to do is run the normal create React app node application. You give it a name, and instead of leaving it blank there, you go ahead and add the template for TypeScript. What that's going to do, it's going to build your project just like create React app normally does, but it's going to make everything a TSX file instead of a JSX file, and you'll be using TypeScript. Now, most likely you're not starting off with something brand new. You are probably starting with an existing app and you need to convert it. So how do we do that? Why do we do that? And what type of benefits do we actually get from this? So I have an example that we're going to switch over to now, and from there we can show what a conversion actually looks like. So here we have a basic to-do list app. The goal of the app is to allow a user to enter some to-dos and complete them as they're finished them. So the way that the app should look is, when we click add, you see a card to complete, and you can complete it just like so. However, what happens in the event where our app is not working properly and we need to figure out how to fix it? So in this scenario, we can type in test. However, when we click add, nothing renders, and we don't even get console output. This can be extremely problematic because the application is not doing us any favors by telling us what's wrong. And the only avenue we have to take here most likely is either stepping into a debugger or console logging out a whole bunch of stuff to figure out where something is breaking. However, let's try to fix this a different way. Let's go ahead and switch our JavaScript application over to a TypeScript application and see if the compiler helps us out instead. So inside of our Visual Studio Code instance, we have the application open, and we can start taking a look at it. The application itself starts at something called app.jsx. This is the main landing page for our app. App is in charge of maintaining the state of the to-do collection. So as we add to-dos, app is going to be the one that owns all of that state. We fire that up by using the useState hook, and that returns us the 2 elements in the array, the first one being the value and the second one being the function to set. Next up, we have a helper function that allows us to take a to-do and add that to the set or to the array of to-dos. And then we call set to-dos to go ahead and update the state value. One thing to note, if we simply tried to do something like to-dos is equal to to-dos, to-do like this, while this would update the value, we are setting that value outside of the React pipeline, and it would have no idea that we actually updated it. So it's imperative that we use this set function. That's the only way that you can update to-dos. Next, we have another helper function, which is complete to-do. This is going to take a name of, or a title of a to-do, and it's going to come and look at every single one of our to-dos to find the ones that match that name, and it's going to go ahead and complete them. Otherwise, it just returns them, and we take that collection or that array of to-dos and set that to the new state. Below that, we have our view. The big two players that we want to pay attention to are to-do input and to-do card grid. To-do input is our input control that allows us to type in a to-do name, and it also gives us that add button. It takes props. This is deconstructed here, but it takes one prop, which is add to do. That is going to be the method in which this function knows how to add a new to-do to the set or the array of to-dos. It's also going to set up its own state to keep track of the text that's inside of that input box. So we fire up a helper function here, which helps us when we click add, so that it can add the to-do to the existing array, and it can also reset our to-do name back to blank. That way it doesn't hang around. Other than that, there's not too much going on here. We have our input control as we expect. We always give it the current value of the name state. And when you change anything in that text box, so you type, we're going to go ahead and update our to-do name state. When you click the add button, it's going to fire that one click function, and it should add our to-do to the array of them. If we go down the other avenue, we have our to-do card grid. This displays all of our to-dos. It takes a couple different types of props. So we expect to have chunk size, perhaps. It could be undefined. But this is going to be how many cards per row we show. After that, we break up our array of to-dos into groupings of whatever that number is. So if we had 7 to-dos and our chunk size was 3, we would end up with 3 groupings. A group with 3 to-dos, a group with 3 to-dos, and then a group with 1 to-do. Then once we have that information, we can go ahead and iterate over our chunks. We create a row for every grouping, and we go ahead and render each one of our to-dos. A to-do is represented on the screen by this component called to-do. This takes some properties as well. We have completed, which is going to determine if this to-do is completed or not. We use that to determine if the title should be struck through or not. And then we also hand that property down to complete button so that it knows if it's completed or not. We also have another prop, which is complete to do, and that is a function that takes a string, which is the title, and that allows us to mark this current to do as complete. Complete button is simply a button that takes in props which are complete to tell if it's disabled or not, and then a function that allows it to complete a to-do. So we are going to go ahead and convert all of these over to TypeScript files instead. The way we do that is we simply flip the .jsx to a .tsx. This will tell the TypeScript compiler and transpiler that these are now TypeScript files, and they can start interrogating these for types and making sure that we are using all of our tools appropriately. So as I go along, you'll see that things start flashing up in red already. And actually, if I switch over to the console here, you'll start seeing that we have a bunch of errors already. If I go over to my app, these are also represented in the app as well. We didn't have these before with the JavaScript version because it didn't have the ability to check for these errors. So as we can see in our app file, our component is showing a lot of different errors. Our first one that we're going to tackle here is this one, which is saying that to-do cannot have a type of any implicitly set. TypeScript over the years has changed so that they are trying to get people out of the habit of using any to start or relying upon it. As we talked about before, any means that you are not using the compiler at all. You're saying this could literally be anything. So over the last couple of years, they've really pushed towards making people explicitly state that they're using it. More of a so we can fix that by just stating any here. But this should be kind of a red flag. You should only be using any if it's really what you intend. I'd say most of the time you can probably define it with a type. In this scenario, we can. We know that we're going to give a title to a to-do because we type it in the box, and we know that it's going to be completed or not because we checked for that throughout the app. So what we're going to do instead is use this definition that I've made already called I-to-do. It lives in this declaration file, which you can know it's a declaration file by it having a d.ts extension. Since this is just a typing file, it doesn't actually ship once you transpile it. It stays with the rest of the types. So we're going to use this type instead. We'll go ahead and import it in, and now to-do is of type I-to-do. However, we're still getting errors inside of this when we call set to-dos. When we hover over top of it, it says that I-to-do is not assignable to type never, which is strange because what is never? If we look at to-dos, which is our array, it says that it's an array of never. Never is a special type which essentially says that TypeScript can't infer what this thing is, and it probably won't ever have an actual type. The reason that is happening is because we have given useState an empty array to start with. TypeScript does not have a way to tell if it's going to be anything else, so it just says that it's always going to be an empty array. So we need to go and hand it its type parameter to tell it what we want this state to be. And what we want it to be is an array of to-dos. And as soon as we do that, now the add to-do function is happy. It's because we are now combining a single to-do with an array of to-dos, and we hand off an array of to-dos to update our state. Next up is the same exact error as before. It's saying to-do name is not valid, or is implicitly any. We know that to-do name is going to be a string. We saw that before, so we're going to just give it the string type. But we get a red error here, and it says that name does not exist on type to-do. Without this error, we would actually get a different bug if we shipped it the way that it is right now. We would always be comparing undefined to to-do name, which means that we would never actually complete anything. So TypeScript steps in and says, hey, you're working with something that doesn't exist. And what this is that I used the wrong property. We can use autocomplete here to see that what I actually wanted was title, which is of type string. It matches what we're comparing to, and now that one's happy. Let's go ahead and we'll ignore to do card grid for now, and we'll jump into do input. So the first thing we got to do is we have to type our props. We saw this before. I am going to elect to use the route of just typing the parameter that comes in. So this is going to use this interface that I've built. And right away we can see that the compiler is happy, and now add to do is a function that takes a to do and returns nothing. Overall, everything looks good here. Let's jump back to app.tsx. However, we'll now see that we've got a new error. And it says that this function that takes a to-do array, or an I-to-do array, is not assignable to a function that takes a single one. So what's going on here? If we look at this, we're actually using set to-dos instead of add to-do. So this function expects an array, but we want the function to take a single to-do. So let's go ahead and instead use our function. And you can see that it is happy here. So let's go ahead down to do card grid. Just like all our other ones, we have to do the same exact thing. We've got to type our props to start. Let's go ahead and bring in I to do. I to do card grid props. This one's pretty easy. Looks like everything's square away in terms of types here, so no issues. Let's go down one level further into to do. We're getting our red squiggly again because we have an implicit any. So let's fix that by giving a type to our props argument, which is a title, a function to complete, and a boolean that tells us if it's completed or not. As we look through, we can actually see that these are all typed properly now. So you see this is a string now. Complete to do is a function that takes a title, which is a string, and returns nothing. So this looks happy. Let's dive one last level down into complete button. We'll go ahead and give it our type as well. This takes two props, which is completed, which is a boolean, and complete to do, which is a function, which doesn't take any arguments but returns nothing. We get an error right away, and it says, property complete does not exist on iComplete button props. Did you mean completed? So not only will TypeScript recognize here that you are using the wrong property, but it's also smart enough to say, hey, this looks pretty close to this other property. Is that what you meant? You can go ahead and just type change the word to completed if you want, but TypeScript will actually give you a suggestion to change it to that as well. So you can use your IDE to take care of that. All right, so we're green across the board. Things are looking good, but if we go back to our console, we still have errors. So let's jump back up to app.tsx, because that's where the problem seemed to lay. So we got a new error here. This wasn't here before, but we can see that this is very similar to the last one we just fixed, in that it's saying property completed to do doesn't exist on this component. Did you mean complete to do? You can go ahead, change the spelling, just like last time, and that is fixed. Our last problem is something that we would actually normally see at runtime. And the problem here is that to do card grid returns an array of elements. However, React doesn't know how to mount that appropriately. When you return your JSX, you have to give it a single root element. That way, React knows this is being mounted to this tag above it. If you don't do that, it doesn't know which one it's supposed to actually print, or which one it's supposed to mount. So it's very nice because TypeScript tells us this just by looking at the types, rather than us having to make it all the way to runtime to figure this out. The easiest way to fix this problem is to just shortcut and put everything in an empty fragment. This empty tag just essentially tells React, hey, I need this, this collection of elements to just live under one common root. So we go ahead and we fix everything. We're still getting some errors, and that is because this all needs to be executed, so that way it knows that it's children. Wrong spot. So now we have an empty fragment with inside of it an array of elements that it'll go ahead and list for us. So we save that. We can see now that app.tsx is happy. I can go over here. We have no issues found. We come back to our app, add something in here, and we see our card. When we complete, it completes just like we expect it to. And our app works just as expected now. So that brings us to the end of the talk. I do have some further resources if you do want to learn some more about TypeScript. You can look at the TypeScript Playground, which is hosted by Microsoft. You can go to the TypeScript Playground and just type in TypeScript in a browser. It's a REPL app, so you don't have to install anything or anything like that. You can just write some TypeScript there, and it'll actually show you what it transpiles to in a pane right next to it. So if you're just playing around or you want to know what you're actually shipping off to the client, you can take a look at it there. Next is a online resource. It's a Git book called TypeScript Deep Dive. This has been around for a while, and it's continuously updated. It's a really good resource for best practices and just really good detail on basic and advanced fundamentals for TypeScript. If you haven't worked with React before and you want to give that a shot, you can use the React tutorial, which is a tic-tac-toe game. And if you use that create React app command that I gave before, you can actually write the whole thing in TypeScript. As I mentioned previously, I didn't show you how to change the transpiler for our demo app. But if you do want to go through that and you want to convert your application over, you can go ahead and follow the link there, and it'll give you the couple commands that you have to run. Lastly, if you like React, if you like giving presentations, you can go ahead and put them both together. Spectacle is a presentation framework that's built in React, and it allows you to create your slides using React. You can also use TypeScript as well. This presentation actually is built on Spectacle, so everything that we've been seeing on screen is just a big React application that's written in TypeScript. With that, once again, I'm Justin Cronin. Thanks for coming.
Thanks, Justin. Tom, what did you think of this evening's talk?
Dan, do you remember, was it early 2000s? I don't want to put a date on that one. Developing
Dynamic
JavaScript.
Drive.
Exactly. Developing in JavaScript. Yes. No developer tools. No.
Dynamic HTML.
Yeah. Firebug, I think, was not even developed.
Well, I was going to say good old days, but
yeah, the good old days. Ajax was just came out, and we're like, oh, this is exciting, and there's a 700-page O'Reilly book on it.
Yep.
Yeah, those are good. So going from there, the invent of TypeScript, just the ability to have readability with code has been huge to our team. I know it's still JavaScript under the hood, but just the ability to understand and enforce those types and not have random errors happening all the time from your JavaScript code has been useful, I would say.
Yeah, I mean, to me it's just sort of interesting where things have come over the last 20 years, right? I think JavaScript started server-side, obviously that sort of faded off, dominated client-side for a long time, and now things like Node obviously back on the server-side. And the emergence of frameworks, Angular, React, Vue, and then sort of like some of the language things at top of it, whether it's TypeScript, WebAssembly, just sort of interesting. I'm personally, having done a lot of full stack in the past, I'm excited to see where things continue to go. So,
you do some more full stack in the future, Dan?
Maybe, but if you're interested in doing full stack stuff, we do have a fair amount of that at ClearEdge, as well as analytic development, DevOps, system administration. Sort of runs the gamut. So if you're interested in tonight's talk, interested in learning more, doing more about this, I encourage you to take a look at our website, careers.clearedgeit.com. We have a fair number of unique benefits, I think, in our industry. So I know folks have been registering for their time at the Ocean City condo the company has, free for employees, and I heard we're giving away another Tesla this year. So
I did hear that.
Hopefully this year. I know logistically things are challenging right now. Getting vehicles is challenging, but giving another one of those away soon. So looking forward to that. So I don't know. With that, you want to wrap up, Tom?
Sure. Yeah. So this is the last call for drawings. Feel free to click on that link and sign out. Right as we sign off, we'll be doing the drawing, and we'll reach out to the winner via email. Also, as a reminder, always be sure to follow, like, and subscribe. Subscribe and ring that bell, as Dan likes to say. And thank you all for joining, and I hope to see you again soon.
Have a good night.